All right, so there are 3 different forms of a quadratic equation. Okay. The first form is going to be the form that you're going to see it in most often. Okay, and this is called standard form. Just like linear equations have a standard form. Y equals, anybody remember?
No.
Thank you. Y equals mx plus b is a standard form of a linear. Okay. Your standard form of a quadratic is in the form ax squared plus bx plus c equals 0 or equals y. In order for you to actually do anything with the standard form, it has to be set equal to 0 or f of x or y first. You can't have like 4x squared plus 2x equals 4. You need to move that 4 before you can do anything with it. Okay, so keep that in mind. It always has to be equal to 0. Okay, so your graph could be something like, I'm just making these up, 2x squared, yes, plus 3x minus 7 equals 0. Okay, so I'm going to show you how to do all this on the calculator. So please, before you plug this into y equals, I need you to do second plus 712. Clear out everything that's in there because I don't know who messed with what on the calculators. We do some crazy, crazy stuff in discrete. So they mess with a lot of things on here. So you're better off clearing it out first. Second plus 712 will RAM clear your calculator. So when you do that, your calculator should look like this.
Okay, you go second and plus.
Second plus 712.
All the way over to all.
I need to make myself a big huge sign for that. Second plus 712. We'll put it right there for now. Okay. So once you've cleared out your calculator, I need you to go to y equals. If you can't find any of these buttons, I need you to, excuse me, Miss Smith, help me, help me. Okay. So you're going to plug in the calculation or the equation, 2x squared plus 3x minus 7.
Okay, we put the little caret in too.
Yes. Okay, so let me show you that. This is the same thing as 2x squared. That little caret tells you that that 2 is an exponent. So I don't care which way you put it. You've got both of those options. Okay, questions? All right, I'm going to clear that out, though, because I only want the one. So if you hit graph, it graphs it for you. Okay, so some things that you can see from the graph. Vertex, what else do we know? We can find the axis of symmetry once we have the vertex. We have how many roots? 2 roots in this one. Okay, domain and range we'll be able to find. So, does this graph open up or down? Up. This one opens up. Okay, so let me show you how to find a vertex first. So I need you to hit second and trace. And you get this lovely, lovely picture. Let's calculate. Okay. So my graph opens up, you said, which means, do I have a max or a min? I have a minimum. Okay, I have a minimum. So on your paper underneath vertex, I want you to write minimum or just min. Underneath vertex, sorry, I'm right here. Let me back out of this for a minute. I'm right here on the vertex part of the paper. Okay. Everybody see where I'm at now? Okay. Perfect. Okay. Whoa, wrong way. Back up. All right. So you want the minimum. You've got two options. You can hit number 3, which will take you directly there. Or you can scroll down so 3 is highlighted and hit enter. Either way, you should end up with this. Okay. It should say left bound, and it should tell you x is 0, y is -7. And you see this little blinky dot. Okay. So x equals 0 and y equals -7 tells you right now where your dot is that's blinking at you. Okay. What you want to do is you want to use the left and the right arrows, just left and right, never up and down, to get as close to that vertex and where you see that vertex is as possible. Okay. So right now it looks like our vertex is somewhere between -0.85 and -8.1. That's not an exact value, but your calculator will find it for you. Okay. So once you get it as close to that vertex as possible, what's it asking for? What's written there? And it has a question mark. Left bound. So once you're at the vertex, I want you to go 1, 2, 3 spaces to the left because it wants a left bound. And hit enter. Now what? It says right bound. So go back to your vertex. And now go 3 spaces to the right. 1, 2, 3. Okay, so what you're doing there, let me show you what you're doing. So, hold on. I think this will help.
I didn't get that.
Oh, stop and please let me explain. Sitting here and telling me I don't get that when I'm trying to explain to you what's going on. So, we think our vertex is somewhere here. Okay, when you're finding left bounds, you're telling them my vertex is somewhere in between here and here. So you're giving your calculator a range of where your vertex is going to fall. So I want to go a little bit to the left of where I think my vertex is and a little bit to the right. So I give my calculator a little bit of a range to find it. Okay, so that's what you're doing. We can do it again once we're done here. I'll go through it again, okay? But that's exactly what you're doing. Is you're telling me my vertex should be no farther to the left than here, and it should be no farther to the right than here. You're giving it a range to look for. Okay? When it says guess, I want you to get as close to that vertex as you can and hit enter.
Close to what?
As close to the vertex as possible. And when you hit enter, it should say minimum. It tells you you have a minimum. And your vertex is at -0.75, -8.1. So underneath where you wrote minimum on your vertex, I want you to put -0.75, -8.1. Okay. You want me to run through that one more time on how to find the vertex?
Yes.
Yeah.
We're going to do it with 2 different forms of the equation too, but I will run through it again, okay? It's not a problem.
Said, minimum -7.5 or what else?
-8.1.
But if you turn on calculator and tells you what you have to go to, like you get less than you go to -7.
Hold on, that's a good question. Yes.
So you always just go like 2, 3 steps to the left, 2, 3 to the right.
I always go 3 and 3. That way it gives it enough room. Okay. So, again, to start this process off, once you put okay, you need to choose what you want. I think I have a minimum, so I'm going to pick 3. Move your little blinking dot as close to that minimum as possible. And then follow the directions. It wants you to move to the left. Tell me that my graph, my vertex should be no farther than this to the left. So I want to go at least 3 steps to the left of where I think my vertex is. And I hit enter. See how this little arrow comes up here? That's saying my vertex should be no farther than that arrow. Okay. Take it back to the vertex. And now I want to go to the right of it and hit enter. You can go more than 3 spaces. I suggest 3, but you want to go to the left of it and you want to go to the right of it.
Is it a different number?
Okay. No, it should give you the same exact number. Go back to the vertex as close as possible and hit enter. Okay. This time, take a look at what it gave me. Negative 0.7499999997. What does negative 7.4999997 round to? Negative 0.75. Okay. That is close enough to negative 0.75 to round that. You can't get any closer. Okay. And negative 8.1.
You could get closer.
What? Because it says 7 instead of 9 again? All right, smarty pants. Teron's got to be a smarty pants. Okay. So, let me go back to this paper first. Yeah. So, right now we're here. Okay. So, if my minimum is at negative 0.75 and negative 8.1, what does that mean my axis of symmetry is? X equals negative 0.75. What? That's not your minimum, though. It's your y-intercept. It always starts you off when x is 0. It's your y-intercept. Okay. So, some miscellaneous things that we can pull from here. You can tell me where it crosses your y-axis. Okay, so you've got 2 options to find your y-axis. Okay, you can go to second graph, and that takes you to your table. What do we know about our not our y-axis, our y-intercept? What do we know? X should be 0. So where does it cross my y? Negative 7. Okay, if you don't like to use your table, another way you can do this is by hitting second trace, and you can calculate a value. So you hit 1, and they want to know, what do you want x to equal? Well, I want it to equal 0. Enter, which means y is negative 7.
That's the y-intercept.
That's the y-intercept.
Oh.
Boom.
Yeah.
Okay, so we've got a y-intercept. You can put this under miscellaneous. Y-intercept at negative 7.
Second trace intersect. Does that work too?
Intersect shouldn't work.
Because that's what I got.
Intersect's only when you have 2 different graphs. It shouldn't work. Don't. Just because it worked on this one, I'm not guaranteeing it's going to work on all. Okay, so just be careful.
Can I see how you wrote it?
So how do we know what we want?
If it's a y-intercept, it's got to be on the y-axis, which means my x value is 0.
So it's always going to equal 0 for the y.
Yes, because when you're on the y-axis, it's always 0. What, the way I wrote it on the paper?
Yeah.
Woo! I just did that.
What is miscellaneous?
Right.
Just other random things we know about the graph. Okay. You could have also written this at 0, -7. That's also a y-intercept. Okay. All right. Back to here. How many roots did you say I should have? 2. Okay, we need to find these separately. Okay, so we're going to go back to second trace. What's another name for a root? 0. So we want choice number 2. Okay, so you need to tell me this. Do we want to find this one first?
Yeah, that one.
This one first? All right.
Yeah.
So just like you did with the vertex, it's the same things except you chose 0 instead of minimum. So use the left arrow and move this dot as close to that as possible. Use the left and right. Do not use up and down. Left and right only. Do not use up and down. Because up and down, and when I have 2 graphs, it jumps it from graph to graph. Like it moves it from the Y1 graph to the Y2 graph. Okay. Because your beacon and how we're moving it is how you would read a book and how you actually read a graph, which is why it would move left and right. So again, what's it asking for? Left bound. So go to the left.
You put enter, go to the
Why you going there?
left. Why you go up there?
Because that's to the left
How many
of
times
where
have
my
we-
point
oh,
is.
Okay, I got it now.
You
Don't go down, you go to the left, not the right.
Right,
Can you
left.
do it one time? 'Cause you do it
Why
3
is right
times,
here,
you
so
don't-
one like this? It's not.
All right, all right. Just watch what I do for this one, and then we'll do the other one together. Okay. So as close as you want it. And I know it doesn't look like much, but when I go up, I'm going up and to the left. So when I hit the left, it's also going up. But it's still moving to the left from where this is.
Oh, so that's why you want 3 spaces, because you want.
I wanted to go far enough to give it a bigger range to look at. Okay. So here is what I'm trying to find. I want it to go to the left first. Once you move it to the left, I need you to hit enter. Then you go back to it. Now it wants you to go to the right of it. So I go to the right of it. Well, as I go to the right, my graph goes down. Hit enter. Again, go back to it and hit enter one more time. This crosses my graph at -2.7. We'll do 77. -2.77. Okay. A lot of kids look at this and say, well, that doesn't say y equals 0. That's a problem. What does that say, Ms. Smith? Okay. So we're going to go sciencey here. You ready?
Oh, no.
Oh, no.
No, it's-
Do you remember scientific notation?
Yes.
Yes.
No.
Every 1.5000000000.
Okay. So this and this are the same thing. So what this is telling me is I need to take this decimal point and go 12 spaces in the negative direction. So my number is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 5. This is my number. Okay. No. No.
See, because you went back to the thing and hit enter, but I didn't go back. I just hit enter and it gave you 0. Is that still okay?
Yes. So some of you will end up with y equals 0. Depending on where you put it to guess, sometimes you'll get this. But this is a very, 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 very small number. This is as close to 0 as you're going to get. So that is okay to see. So you want that to say y equals 0 or y equals something e to the -15th or -12. That just means it's a very, 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 very small number. Okay. That is okay. It's just how your graph rounded it. Don't panic.
So why do we learn this in science? Or when do we learn this in science?
I don't remember what science you do scientific notation in.
I'm never been doing
Biologist.
science.
Is it biology?
It's not biology.
I heard of the word. No, skip.
It's not the other sciences.
Well, it's not biology.
You didn't learn this in any middle school sciences?
I was not in math.
It wasn't in math.
Yeah, I learned.
8th grade math?
Yeah, I learned about the little 12 and the power.
But see, our teacher was terrible, so.
Yeah, it is.
Okay.
What thing we put that in?
We don't do that again.
Huh? That's a root. Negative 2.77 is a root. Okay. You told me I have two. I've got one on the left and one on the right. So try this one with me. Okay. So again, I'm still looking for a 0. So I need to either highlight number 2 and hit enter or just choose number 2. But this time I want the root on the right. So I need to, again, use that right arrow, get as close to that root as possible, and then follow my instructions.
That's dead on the line.
On mine,
That's-
it gave me a
No,
0.
it's not.
Or it gave me the answer.
Lucky you.
Ow,
I hate you so much right now.
I already figured.
It's just how his button fell. I hate you so much right
You
now.
push enter.
But, okay, so we're at where we want to be, or as close to it as we can. I want to go to the left. 1, 2, 3. Well, when I go to the left, it also goes down. Hit enter. Go back to it. So I need to go back to the right then. Now I need to go to the right. When I go to the right from that, it's going up. And go back to it and hit enter.
See, this one, my zeros, my Y says 0.
My Y says 0 too.
So it could work.
It's all depending on how your calculator guesstimates it.
I got
Yes.
I call it a guesstimate. It's like an estimate.
1.27.
Yes, ma'am.
We'll have to work this one right here.
Can I see how you wrote this one? Make sure I wrote it right.
This one, see, I understand this one, but it's.
I just
the same.
put roots and then put the 2 numbers.
Did you put one on top of the other or one beside of it?
Doesn't matter. Either way works.
I know, but we did the same thing for both, right? But I need to go do this.
So how I put them?
Even though we did the same thing on it, you know what I'm saying?
Did you put one
Just
point?
like you did on your homework. Roots and then give me the 2 numbers.
For graph?
Duh.
Oh, we're not worried about the graphic now.
Did you put 1.26? I mean 27 or 1.3?
1.27. It's all going to depend on how they ask you to round it.
Roots will be 1.27.
Negative 2.77 and 1.27.
You could.
I got a question. I think I know how I got this. I think I got it because I pressed enter the first time. I pressed enter twice.
On the.
And
Let me see.
Everything.
Wait, so you went to 0?
you know the first time, she said if you press enter, you'll get the right answer. You get the answer immediately. I did that, and I just moved my thing once it's over, and it took me straight to
So what else do we do? Like,
Wait, so you went to trace and you hit 0.
No, like you supposed to leave it. So you know how you found the first one? You know how you found that on this side? You know how she said press enter, and it goes like the y equals 0. You know we were figuring out this side.
She was just saying when she guessed it, it just came up y equals 0. She didn't do anything.
Oh, I pressed enter, and it gave me y equals 0.
It's not foolproof. I don't know what that did. It's not going to do it every time.
So they have a lot home. So
Okay, so you can also put this
2 homes.
0 and then 0. Like you can still put this comma 0, this comma 0.
Mm-hmm.
It's flat too. At least
We're not worried about that right now.
I'm just telling you.
Okay.
Enter it up.
Please pardon the interruption. Please dismiss all members of the tennis team at this time.
Y'all are on the list. Nobody cares.
You want to?
Your name's not on the list. You don't get to go. Okay. We have a second form of this graph.
Not for the men. Yeah, I do.
Okay. Y'all are gonna be hurting if we don't get through this, and I'm still quizzing you tomorrow because I'm tired. Yes. Quiz tomorrow. It is open though. But if you don't know how to work this calculator because I don't have time to work through these problems with you, I'm not helping. Yes. I've not gotten an email from him.
Zakai, you so worse.
I'm just trying to be comforting.
Okay.
See, not paying
Oh, what was grab?
Oh, we're not doing this.
Ooh.
Will it always be like that, Miss Smith?
In vertex form, yes. I don't even know where my phone's at. This is my email. Because I can't switch my screen with it recording. I'm about to get really irritated. Nobody's going to leave this room until my phone's down because it was here when y'all walked in.
Somebody call it.
Never mind, it's right here.
That was
I mean, I used.
Hey.
Did you move it?
Oh, is that what you did?
Oh.
I put it over there.
Oh,
I was-
you're making me nervous. Don't do that. Early dismissal. It says 3:15. You hear me? It says 3:15. Okay. We are never going to get through this.
Shut up.
No, it's really frustrating. Okay, so vertex form is going to look like this. How do I know that this is a quadratic still? No.
Okay.
Every equation can equal 0.
Okay.
How do I know that this is a quadratic? What you got, Teron?
Because it has 4 different variables.
No.
Because you want. There's
What you got, Bree? This right here.
I was gonna say that.
Squared. When your leading term is squared, that tells you it's a quadratic. Linear, you just have x. When you have a quadratic, you have x squared. When you have a cubic, it's x to the third. Okay, you'll learn cubic back in math 3. It'll be fun. Okay, so we're going to use negative x minus 2 squared plus 4 equals 0. That's what you're going to put into y equals. Again, clear out your calculator. It makes it easier if you just clear it out every time.
Y equals.
I have a question.
Yes.
Y is 0.
Yes.
So y is equal to 0.
Huh? Yeah.
You gotta put the parentheses.
Your equation's equal to 0. So you're trying to find what x is when y is 0.
Then we put that in Y equals. Y equals.
Yes.
Y'all so loud.
So this is what you have in for y equals. Whoops, wrong one. Okay, again, you could have used that caret in the 2.
Is that subtract 2 or negative 2?
It's negative. You cannot use the subtraction sign. It will error you out. Or it will assume it's a negative 1.
Why, how could I assume it's 2?
X equals 0, y equals 0. That's what it says.
Okay, so make sure you use the negative button here and the minus sign here. Or else it will.
Wait, so that's
It'll
a
come up.
minus or that's a negative? The one in the
This is a negative. This is a minus.
Negative is
Shorter. It wouldn't be
Yes.
X negative 2.
Negative is over there with all the other operation buttons. I mean, that's subtraction here. The negative's up there with the numbers.
You ain't said nothing that I don't understand.
Dude, negative is at the bottom.
Okay, I got it now.
you acting like you don't.
Really?
No, because she said it, so I got
Right,
it.
let's go.
Okay, shut up. Go ahead.
So who you talking?
Okay. What do you notice about this graph that the other graph didn't have?
It's supposed to
You have a
be down.
maximum.
This one goes down. This one has a maximum. What do you think made that happen?
It being negative.
That negative in the front. We're going to talk about that a little bit later when we talk about transformations. But that's what changed it and flipped it upside down, the fact that I've got negative. So if I would have changed that 2x squared to negative 2x squared, that would have flipped your graph upside down. Okay. So I've got a maximum this time. So underneath vertex, you can write maximum.
Wait, are these only for?
Okay. So we've got a maximum. Wait, were you asking about maximum?
Yes.
Maximum can be any form. But we have a maximum on this one because we've got a negative in the front. This one was a positive in the front, so it opened up. So we had a minimum.
Can I work like that every time?
Okay, so this time when I go to second trace, instead of a minimum, I want choice 4. The same rules still apply. After you choose it, it's the same thing. Move it to the right to get it as close to that maximum as possible. They want a left bound first, so go to the left. Hit enter. Go back to it. Now go to the right and hit enter. Go back to it
Wait, I think I messed up.
and guess.
I got 2 and 4.
You said
Yeah.
closer to birth.
2 and
I
4.
don't know none of that.
I messed up.
I got 2. All I did is just click where I was.
Yeah, I took it.
Whoa.
I was in there.
I got 2.
I'm sorry.
I got it.
I hate Google, bro.
I moved 3 spaces up. So
Now go to the right
You go off off me, yeah.
and hit enter. Go back to it.
I got 2.00001.
That's what I got.
Okay, so some of you got 2.00001. Okay, I got 1.9999999. Some of you got 1.9999974. Okay, it's as close to 2 as you're going to get it. Okay, so your vertex is at 2, 4.
for vertex?
Yes. You good? Okay. Find your y-intercept. Again, either use your table or find the value. What does my x have to equal if I'm on the y? 0.
So 0.
Okay, so I can do a value, 0, 0, or I can go to the table, and guess what? 0, 0. So your y-intercept is at 0. Your roots. Second trace. It's the same thing as a 0, so I want that. Second trace. And you want 0. So choice number 2. Okay. Well, I'm as close to that 0 as I'm going to get right now. So I'm going to move it to the left and hit enter. I'm going to go to the right and go back to it, and then go to the right of it and hit enter. And go back to it. 0, 0. Sorry, I hit enter twice and it bumped away. It was 0. The y-intercept and the x-intercept are the same thing on this one.
So if you figure out the root and it's 0, then can you do that?
No, it's not automatically.
Always be the same?
Actually, yeah, it will. If your root is at 0, your y-intercept will always be at 0
Yeah, you probably.
because it crosses at the origin. Okay.
That was for the first root.
Okay, thank you.
Okay. So I need that second 0. So I need to go to the other side now. Okay. Here's where I think it is. So I want to go to the left of it, hit enter, go back to where I think it is. Now go to the right of it, hit enter, and then go back to where I think it is and hit enter one more time. This crosses at 4. So your roots are 0 and 4.
Wait, how did you do that?
Left 30, right 30, right 30.
No, I'm talking about the second term.
0. Your 0 is the same thing as a root, which is the same thing as a solution, which is the same thing as an x-intercept. Okay, should go under your miscellaneous, just like we did with the first example. Okay.
I got X. Did you get X before the last root? Or did you get X?
So this is what you should have for this one right now. Okay, your axis of symmetry should be x equals 2. Okay, do me a favor. Take a look at this equation. Oops. Take a look at this equation and take a look at your maximum value.
Oh my God. What?
Whoa.
Negative H, which is negative 16.
Take a look at the equation and your maximum value.
So
Oh
H
my-
and K are always going to be same G? The two numbers.
When it is in vertex form, that means that I've given you the vertex.
Woo, that makes sense.
This is the y part of your vertex. Is positive 4. Your x, okay, it's x minus 2. This is positive 2, though.
Because of the negatives on the outside.
This happens because you would technically set x minus 2 equal to 0, add 2 to both sides, and get positive 2. And that's why this is positive 2. Opposite, always. So if I had x plus 4, my vertex should start off negative 4. Okay, so there are some fancy things that your different forms of the quadratic can do. Okay, last form.
You can't do.
Adios, friend.
Wait,
Is this yours?
ID. ID.
Okay, last form. Intercept form.
You okay, Bubba?
Good luck, Troy. A Q?
Yes.
Oh. I thought that was just like.
Oh, I forgot to put the A outside of here. Sorry, there should be an A to the left of that first one. There should be an A to the left of that first one, just like there was an A to the left of. Sorry.
You have whiteout?
You're not gonna have to memorize them, but if I give you an equation, you should be able to tell me what form it is.
You have whiteout or no?
Okay. So this is the best part is 2 sets of parentheses, intercept. 1 set of parentheses, vertex. No parentheses, standard. Okay. Yes.
You still have to spring your clock over.
I know.
Remember this.
Listen, this just means we have an extra hour and 12 minutes, right?
No, that's not.
Hour and 12 minutes.
Oh.
Is it only like?
I love Miss Smith, but you know.
I understand.
It's not even about Miss Smith, it's about the fact you want to get home.
Right. But you want to eat.
My
You know what I'm
back
saying?
hurt.
Okay. So here's the last one we're going to graph. Okay. So this one's an intercept form. So what kind of information do you think we could get from just looking at the equation?
Intercept.
The intercepts. Woo!
Please pardon the interruption. Please release all members of the track team at this time.
What?
You see a charge over there?
I did not see a charger over there, but again, I had third
They
period.
do do.
I'm sorry, but I've got seniors and they probably swiped it.
What charge is this?
Nobody in here charges, so. Is that not yours?
Who's this? This. You should pull up.
Josh, you know that one. I don't know who that belongs to.
Phoenix! Hey, I miss you.
Okay.
She can see in the video.
You know what?
Okay. This will actually give you the intercepts. So please go to 2nd plus 712, clear out your calculator, put this into y equals. We're going to have to stop here today. We'll glue in everything else. So
Second.
plus 712.
Okay, now.
Plug into y equals this equation. Negative x minus 2 and x plus 4.
I think I'm starting to get used to it a little bit.
A little bit. The more we practice it, the more you'll get used to it. Yes. Or no, just graph. Second graph will take you to the table. Okay, so here's my graph. You all right over there, giggles a lot? Yeah, right. Okay, so do I have a min or a max?
Next.
Next! Okay, guys, we got to kind of hurry or we're going to run out of time here. Okay.
Come on.
Quiz.
Is it a min or a max?
Next.
It should be a max. It opens down. It has a high point. Okay, it's a hill, so it goes high. Okay.
Opposite still?
Huh?
You still put an opposite?
What do you mean opposite?
You know how that says negative? Two. So is that positive too?
Oh, look at Elijah. So smart. Okay. So we need a maximum. So you're going to go second trace. Choice number 4, my friends.
What's my favorite number?
Okay. It's kind of hard to see. Okay. So you've noticed right away, it's kind of hard to see. I want to see a little bit higher. Do you know how to adjust that?
So you gotta zoom.
Oh, I hate Zoom. No, we are not zooming.
Thank
I got a question.
I hate Zoom.
Why?
Okay. Okay. So okay, my window tells me what I can see on my screen. My X-min tells me how far I can see to the left. X-max tells me how far I can see to the right. Y-min says how slow I can see. Y-max tells me how high I can see. You said it goes too high. I need to see higher. So I want to change my Y-max. We can change it to, I don't know, let's do
100.
No, let's not go that far. Let's go to 20. Hit 20, and now go back to your graph.
Oh, Julie.
Oh,
Crazy. Is that the same parabola that we had in the beginning?
yes, it is still the same picture.
I'll make it 1,000 and see what it do.
Oh, it just zoomed in.
Obviously,
It just zoomed up. Instead of zooming the whole thing, it only zoomed up.
That's
How you do that?
But why did you have
So,
to change
hold on,
the-
hold on, hold on. Watch. All right, we are never going to finish this today. Holy cow. It's all right, it's all right, it's all right. It's all right. I can do this. All right. So, come in.
It's open.
Jackie, what do you want?
It's always open.
Miss Harvey, she needs to sign up for tonight.
Why? I can bring it down with me.
Hey Trinity, you riding the bus?
Yeah.
That's just. Yes.
And go to Snickers.
I love that.
Thank you.
You're welcome. Okay. So, let's say I wanted to see something a little bit farther to the left. Okay. So if I want to see something a little bit farther to the left, I would adjust my X minimum because it's going in the negative direction. So I would change this. Please stop talking. I would change this. You can change it -50. The more you change it, the more you see. So look what happens when I go to graph now. Woo! Guess what? That's still the same picture. What? That is still the same parabola that you graphed to begin with. It's just all squished because I made your window bigger. Okay. So it's just squishy.
So
Okay.
no matter how like when you change the numbers, is it gonna be the same? That throws me off. Because you change the numbers, so the graph should be different.
I mean, it looks different, but it's still the same parabola. So I went back and changed my X minimum back to -10. Okay. We're actually going to stop here. We're running out of time real fast. Yeah, we're running out of time. We got to get calculators back and everything else.